Okay, so looking at section 3.4 here, number 35, it's on page, what here? 243. Okay, so 35 is talking about minimizing cost. So my primary equation is going to be what? My cost equation, right? So I'm going to have C equals something there. It says an industrial tank of the shape described in 34, so let's go back to 34. A solid is formed by joining two hemispheres to the ends of a right circular cylinder. Okay, so two hemispheres to ends of a right circular cylinder. What's a right circular cylinder look like? It would be like a can of soda or something, right? So what we would have is like, this picture isn't going to look great or anything here. We would have like a can of soda, and what would adjoining, what does it say? Two hemispheres to the ends be like? It would be like two half spheres, right? So it's like if I took a basketball and cut it in half and attached it to the top and bottom so it fit perfectly. Okay, so then this is going to have like, you know, a dome, yeah, on the top and bottom of it. Okay, so are we understanding at least what the picture's looking like off of my fantastic drawing? Okay, so that might help things a little bit because we need that for sure. Let's see here. I don't know. I don't even know what you'd compare it to, I guess. I'm sure there's things that are that shape, but nothing that just pops out at me. So, okay, let's keep going here. It must have a volume of 3,000 cubic feet. Okay, so that's going to be my secondary equation, right? Our volume equals 3,000, which we'll write an equation for the volume here in a second here. The hemispherical ends cost twice as much per square foot of surface area as the sides. Find the dimensions that will minimize cost. So we're trying to minimize our cost here. And the ends cost twice as much per surface area as the sides. So these are 2 times the cost. Okay. Let's try to write what? What it costs for the surface area of this here is half of what it costs for the surface area of like the basketball piece. Both of them. The ends, yep. Like per square inch. So the material for these is like twice as much as the material for this. Does that make sense to everybody? Okay. Okay, so let's try to write an equation for the volume of this. So what's the volume of like the can in here, the right circular cylinder? We do area of the base times the height. What's the area of a circle? Pi r squared, and we times it by the height, right? So that's the volume of the middle piece. And then if I put these two hemisphere pieces together, wouldn't I just get a sphere? Does anyone know what the volume of a sphere is? 4/3 pi r cubed. So any questions on that? What do we think we're going to solve that for? 4/3 pi r cubed is the volume of a sphere, okay? And this would form a full sphere if I put the two pieces together, right? Okay, so instead of volume equals, what could I write? 3,000 equals, so let's just do that. What am I going to solve for there? H. So if I solve for H, I'm going to move this over first, so let's just try to clean this up a little bit before we even try the primary. So I have 3,000 minus 4/3 pi r cubed, and then that equals this, right? So what am I going to do with this piece? Divide by pi r squared, right? This here, I might want to try to get a common denominator first, just so it doesn't get super, super messy. So the common denominator would just be that 3 that's in the denominator, right? So what's this going to turn into if I want to get it over 3? 9,000. So I have 9,000 minus 4 pi r cubed over 3. Is everyone okay with this? And then it equals this pi r squared h. I'd rather take a little time to clean this up now than to have to deal with it later. I'm going to make sure this looks like a 3. Okay, instead of dividing by pi r squared, couldn't I multiply by 1 over pi r squared? So let's do that just so it's a little easier to see where this goes. So 1 over pi r squared. Isn't that going to just put pi r squared in the denominator here? Okay, so my h here is equal to 9,000 minus 4 pi r cubed over 3 pi r squared. So this is the equation I'm going to be plugging into the primary. This looks like a fun problem. Thanks for asking it. And you're welcome for assigning it. You're welcome. Okay, so any questions on the secondary piece? Okay, let's start looking at the primary. Okay, so we should have the secondary equation done here. This is the equation I'm going to be plugging in the primary. Now the primary equation for this one, I'm trying to come up with the cost for producing something that looks like this, right? So let's say that P equals the cost per square foot. Because isn't area in square feet? Okay, and what I'm finding is the surface area of this, right? And that's what my cost is going to be associated with, is the surface area. So how do I find the surface area of this, like the outside of a can? Think about it as like, yeah, think about it as like a sheet of paper. So look at me for just 1 second here. Okay, you have a sheet of paper, which makes a cylinder, right? If you cut it down the side, then don't you have a rectangle? Okay, so you're trying to find the area of a rectangle, right? And isn't the height of the rectangle going to be the height of the cylinder? Okay, and what is the width of the rectangle going to be? The circumference of that. Does that make sense? Okay, so just think about it as like a sheet of paper that you cut down and open up, okay? So let's write an equation for the price of this here, or the cost for this here. So what's the area, the surface area of that? What would be the circumference? 2 pi r. And what do I have to times that by? The height, and that's going to be the surface area of this, right? Then don't I have to multiply that by the cost per square foot? Okay, so my cost here is going to be P times 2 pi RH. So any questions on the cost? That's just for the middle part, right? Now what's true about the cost of this? Instead of being P, it's going to be what? 2P. So I'm going to have to add 2 times P for that portion of it. And what is, don't I have a full sphere with the top and bottom? Okay, and the cost is this for the whole sphere. And the surface area for a sphere we said was what? 4 pi r squared. Okay, 4/3 pi r cubed is the volume. We're looking for the surface area, okay, which is 4 pi r squared. Okay. So any questions on that step there? Okay, what am I going to do next? What do I have to do before I solve anything? I have to plug this h in, right? That's why I came up with that secondary equation. So we're going to go ahead and put the h in here. I'm just going to put all these variables together for the moment. So 2 pi rp times that. And then back here we have 8 pi r squared p. So any questions to that point? Okay, so the p here is not our variable, right? When I take the derivative of this, what am I taking the derivative with respect to? R. R is my variable. So I'm just going to go ahead, don't both terms have a p in it? I'm going to pull the p out front, okay? And I'll take a 2 with it because there's a 2 in both of them. Then I don't have to deal with it. So if I take 2p out, I'm left with pi times r, which what happens to that pi and that r? Wouldn't they cancel here? Do you see how this pi is in the numerator, this pi is in the denominator? Okay, this r is going to cancel this squared piece, right? Because it's r over r squared, which would just be r in the denominator. So then I don't even have to deal with that. So then I just have 9,000 minus 4 pi r, what was that, cubed? Over 3r. Does that look right to everybody? Okay, now if I took a 2p out of back here, I'm left with 4 pi r squared. Does that look right? And I would probably do the Hart method with this here. You know what I'm talking about, where I split this up into the two separate fractions, because I see if I do the Hart method with this piece, I'm going to have an r squared, and I can combine those together. And it's going to be easier to take the derivative of something like that than to have this quotient, okay? So let's just go ahead and simplify it one more step before we do the derivative. What's 9,000 over 3? 3,000, and then it's going to be r to the what power? Negative first, because our r is in the denominator. Then I have minus, and my number here is 4/3 pi. The pi is in the numerator, so if you want to put the pi up there, you can. And then I have r to what power? Squared, right? Because I have r cubed over r. And then back here I have plus 4 pi r squared. And if you want to, you can put these two together. If you don't, it's not a big deal. And then we take the derivative there, okay? So when I take the derivative, so any questions at that point before I start my derivative? Okay, so let's go ahead and take the derivative. And remember, this is the derivative with respect to r, so I'm just going to put an r there so I don't forget. Okay, when I take the derivative, I leave the 2p alone, and I take the derivative of this back piece, which is negative 3,000 r to the negative second. That look okay to everybody? Okay, the derivative of this piece here, like I said, if you want to put them together, you can. It's not a huge deal. If I pull the 2 down, I get negative 8/3 pi r. And then the back piece is going to be what? Plus 8 pi r. And what do I do with the first derivative? Set it equal to 0, right? So this is equal to 0, and okay, I only did half of the product rule, right? But what would happen if I left this alone and took the derivative of 2p? It'd be 0, right? P is a constant in this case, so we don't need the back piece there. So the first derivative equals 0 when we can't ever have a price of 0 here, right? So we don't have to worry about this piece being 0, but when this piece here is 0. So when negative 3,000 over r squared, I'm just going to write it like that. And then if I combine these two pieces together, what's negative 8/3 plus 8? 8 is how many thirds? 24/3 minus 8? 16/3, so this would be plus 16/3 pi r equals 0. Then I'm going to move this to the other side because it's negative, and I'm not a huge fan of negatives. So I have 16/3 pi r equals 3,000. If I add it, it turns positive over r squared. And then what am I going to do to solve? Well, I have an r squared here, so how do I get it out of the denominator? Multiply by r squared. So if I multiply by r squared, I have 16/3 pi r cubed equals 3,000, right? And then I would divide by the 16/3 pi. And then what do I do for my last step? Cube root. So go ahead and do that in your calculator. I'll do it in mine. We'll check our answers here. Just be very careful about how you put it in your calculator. That's the easy thing to mess up. Yeah, let's just do it as a decimal. Are we getting like 179 about for r cubed? Okay, and then we have to cube root it, so we should get r cubed is 179.049. You might want to type it in your calculator again. You have to make sure the pi's in the denominator. Maybe just divide by 16/3 and then divide by pi. Oh, when you do this? Okay. So I'm going to raise this to the 1/3 power, or you can cube root it if you know how to do that. And we get like 5.636. Is everyone okay with that? What would my label be in here? I think it's in feet, isn't it? Okay, so then how do I check, because what I'm trying to do here is minimize the cost. So how do I check if this is a minimum? You can take the second derivative and plug this in, and then if it's concave, or if it's positive or negative, is it going to give me a minimum? If the second derivative is positive, because that would be concave up, so it would be a minimum, right? So you can either do second derivative test, or we can do first derivative test where you put it on the number line and you see if it's increasing, decreasing, okay? So do we understand how to finish this problem? I know that that's not what we typically have issues with. And does it end up being a minimum? The book says yes, so I'm going to say yes. So we would do our number line. I'll just do, it without doing all the work for it, because then maybe we can get another problem in here. I would put the first derivative here. It's negative, then positive, which means it's decreasing, and then increasing, which means that this is a min, which is what I was looking for, right? A relative min. And then make sure we answer the question. Find the dimensions that will minimize cost. So this gives me what my radius is, right? So my radius is this, but what else do I need to find for dimensions? Your height. So how do you find the height? Plug that back into the h equals, right? So go ahead and plug that into the h equals and come up with your height. And then once you have that, that's your full answer there, okay? So I'll give you guys a minute to do that. All right, number 37 here, minimum area. So my primary equation is going to be A equals. So I'm just going to write that before I, forget what I'm trying to do here. So my primary is going to be to minimize this area. So A equals. Okay, it says the sum of the perimeters of an equilateral triangle. Oh gosh. And a square is 10. I was doing this morning too. Okay, so my primary equation is the area. We've got the equilateral triangle and square have a perimeter of 10. So let's say we let the sides of this be x and the sides of this be y. My secondary equation is going to be the perimeter, right? I know perimeter equals, what's my perimeter? What's the value of my perimeter? 10. So I know 10 is equal to what? 3x plus 4y. And did anyone solve that for a particular variable? Like which one do you want to solve for? It doesn't matter. The y here. Okay, so let's get y by itself. So I'm going to have 10 minus 3x, and what do I do with it? Divide by 4, right? So that's my y. And that's what I'm going to be plugging into my primary. Okay, my primary equation has to do with the area of this and the area of this, right? The area of the square is easy, isn't it? What's the area of the square? Y squared. Okay, that portion, easy. The area of the triangle is what? How do I find the area of this? Half base times height. What's my base? X. What's my height? Yeah, we've done this like a million times, but I have to do it every single time. So let's just do it here. Okay, if this is x, if I cut this in half here, this is a half x or x over 2, right? And then if I try to find the height, can I use Pythagorean theorem to do that? Okay, so, whoops. So I'll go ahead and do that here for us quick, but that's just Pythagorean theorem. Okay, so I would do x squared minus a half x squared, which is going to give me what? If I square the half, I get a fourth x squared. And then isn't that my height squared? Right, because this is like a squared plus b squared equals c squared. I'm just subtracting them. So what's 1x squared minus a fourth x squared? 3/4 x squared, right? And then how do I get the height by itself? Square root. And when I square root, I just get h equals square root of 3 over 2, because square root of 4 is 2, and then x, right? So that's my height. So the area of a triangle here, of this triangle, is 1/2. What's my base? We said was x, and my height is square root of 3 over 2x. Now obviously I can put that stuff together, right? And then what do I have to do with the secondary equation? Plug it in. Now is this what we had trouble with, was the setup? Because from there it's probably not terrible. I'm not saying it's super easy, but if we could do those other problems, that one's very similar there. All right, so I'll give you guys a few minutes to finish that one up.